In this video, we're going to talk about groundwater, how it's made, how it's depleted, how it's recharged. First, with groundwater, let's talk about what it is. So groundwater is water that is in the ground. It makes sense. Since water is more dense than air, air will displace it and push it down due to the forces of gravity. Now, think of the ground as full of air and full of water. If there's more water, the ground will contain more water. If there's less water, the ground will contain more air, just like a glass of water. In this image, you can see groundwater is present right next to the ocean. Any place you have surface water, you're also likely to have groundwater nearby. So how does groundwater occur in rocks? Groundwater is water within the spaces between rocks, also known as pore spaces. So a rock that is more porous means it has more pore spaces, can also contain more groundwater. A rock that is less porous and has less spaces between it will contain less groundwater. So for example, a solid granite contain less water than a cracked or fractured granite, because cracks and fractures can contain groundwater. In this image, we have unsaturated and saturated zone. The unsaturated zone is on top and does not contain full water between its pores. The saturated zone below fully contains water in all of the pore spaces, whereas the unsaturated zone also contains air. The water table is the line between the unsaturated and saturated zone. The water table level can fluctuate depending on how much precipitation and how much water is actually pulled out of the groundwater. You'll also notice that surface water lines up perfectly with groundwater. Wherever the groundwater reaches the surface, you have surface water as either a lake or a river. There are a couple of groundwater zones. In this image, you can also see unsaturated does not fully contain water. There is some air in the pore spaces, and saturated fully contains water. You'll notice that plant roots could be in the unsaturated zone or in the saturated zone. Most plant roots are in the unsaturated zone because roots cannot survive full in water in most instances without receiving air as well. The water table is the boundary between the two. Aquifers. An aquifer is an underground layer of water-bearing permeable rock. If it does not have water, then it's not an aquifer. If it's not permeable, then it's not an aquifer either. It's an aquiclude. Where are they? There is a lot of aquifers. Pretty much anywhere you have land on Earth, there is aquifers, even in deserts. Anything on this image that is not white is an aquifer. So you can see the state of Utah over here has aquifers. Up here in Idaho has aquifers, California has aquifers, Nevada has aquifers, and Arizona has aquifers. There are some areas that do not have aquifers for the most part, but they may still have some underground water. Why should we care about aquifers? Well, 33 to about 50% of the U.S. population depends on groundwater for their water supply. Also, groundwater is used for agricultural purposes, including farming and ranching. And a lot of that comes from groundwater instead of surface water. So groundwater is very important, not just for drinking, but also for food supply. In a lot of instances, humans use pumps to bring up groundwater to the surface, instead of relying on groundwater to come to the surface on its own. We use wells to bring groundwater out of the ground. Now, in this image, the well on the left for this home is pumping. And so you can see the water table drops slightly when water is being pulled out of the ground. If more water is pulled out of the ground, like in this image right here, you can see the water table can drop significantly. In fact, the water table can drop so significantly when a large amount of water is being pulled out that other wells nearby can dry up due to the drop in the water table. Now, if this well were to shut off, the water table would eventually flatten out depending on the permeability of the rock. A more permeable rock would flatten out quicker. A less permeable rock would flatten out slower. There are some adverse effects to lowering the water table besides just lowering the water table. Drying up of wells, as we saw in the previous image. Deterioration of water quality, as we'll see on the next slide. Increased pumping costs. So as the water table drops, you have to drill deeper wells in order to reach the water. And land subsidence. So land subsidence means the land level literally drops because there's less things underground supporting the land. Here is an image showing you what land subsidence actually looks like. In this image, in California, the land level was up to here, where it says 1925. 30 years later, the land had dropped this much distance. Almost another 30 years later, it had dropped this distance again. So land subsidence can reduce the land or reduce the elevation significantly. Usually, if it's evenly spread, it's not an issue. But if it's different areas receive different amounts of subsidence, it can destroy buildings, roads, and cost millions and millions of dollars. Now, water, when being pumped out, can actually become contaminated as well. So in this instance, there is a septic system, and the raw sewage is moving this way in the water table. The residential pump is on the other way, that the water is not moving. So they are not mixing with each other. But if another well comes online to water this farm or this crop over here, the water table all of a sudden switches direction. So instead of moving to the left, now it moves to the right because it's trying to flow into this well right here. And when this residential property tries to pump their water, they're also pumping in raw sewage as well. So that is one issue to pumping out water out of wells too quickly. Artesian or aquifer wells. An aquifer under pressure is an artesian aquifer. When that water comes to the surface on its own accord, it is an artesian well. This can be due to humans putting a pipe in the ground, or this can be due to natural sources such as a spring. When water is under pressure, usually that is because there is a slope nearby, and that slope traps the water in a saturated permeable layer between two impermeable layers. So the water is trapped and cannot go up or down. Once downhill, the water is under enough pressure that if released, it can come to the surface above the force of gravity. If an aquifer runs out of water, can we fill it back up? The answer is yes. Here are a couple different ways. The simplest and cheapest way is literally to just wait for it to rain and to stop pumping water out of the ground. So option number one, at a rate of about 50 feet per year, down to about 50 inches per century, so you can see it's a wide margin depending on precipitation, aquifers will refill themselves. However, it is usually on such a long time scale that it is not feasible for humans. 2. Humans can speed up the process by reversing a well, pumping water back into an aquifer. It could be sewage water or reclaimed water, usually, but this process can be pretty expensive. Pumping costs money and electricity, and building the pumps and drilling them also costs money as well. It is the fastest way to recharge an aquifer, however. The third way is somewhere in the middle, infiltration ponds, like here on the left, placing water into permeable ground and just letting it sit and percolate through the soil. This will also recharge the groundwater, but it has the cost of some of that water is evaporated and lost to evaporation, and also the water itself does cost money to store into an evaporation pond or an infiltration pond. Those are the three ways to refill an aquifer.